we can have this case here. I'm going to say A is going to be greater than 0 and Q will be equal to 0. Okay? A is going to be greater than 0 and Q is going to be equal to 0. Now for that one, it will look like this. The shape will look like that. Okay? And Q will be here at the turning point. That's where Q is. But Q is 0, so we are going to end up having at this point here, that's 0 Q. But our Q is 0, so I'll just put 0, 0 there, and I hope you can understand that. Okay? Q is 0. Okay, in any case, to avoid unnecessary confusion, since I wrote Q equal to 0 there, allow me to write Q, 0Q, like that. Okay, which means the minimum value of the graph is going to be 0, the minimum value of y. Okay, remember Q is a y value. Okay, I just want to emphasize that. Q is y value. Q is a y value. So you get it on the y-axis. Okay? So when we want to write the domain, now if you remember, okay, I hope that you were able to watch the video when I taught domain and range. And I did an exercise there where I discussed how to determine the range in the domain using our knowledge of term one way on set notation, interval notation. So this graph, the domain, okay, the domain of this graph is going to be x is an element of real numbers. Okay, because it goes on up to negative infinity and sorry, down up to negative infinity and also up to positive infinity. The range, now, the range, remember, the range is the set of the y values. The range is the set of the y values. Since the minimum value of y is here and it's equal to 0, okay, here, q is 0, okay, I wrote it there. Q is 0, so y is equal to 0 at this point. Which means the minimum value of y is going to be 0 and the maximum is going to be positive infinity because the graph is going up. You can see with the indication of these arrows here, y is going up to positive infinity. So your range, you can write it as 0 is less than, now you have to include the 0, less than 1, less than or equal to positive infinity, or you can write it as y is an element, open square bracket, and then you put your positive infinity. Okay, so this is how it looks like. Okay, this is when A is greater than 0 and Q is equal to 0. And always remember that Q is a y value. It is also the y-intercept. So the y-intercept of this graph is equal to Q, and Q is 0. So the y-intercept of the graph is equal to 0. Okay? A, which is the coefficient of x squared in the general equation, determines the shape of the graph. Q is the y value, it is also the y-intercept. Okay? Then the second case, we are going to have A, we are going to remain with A being positive. Okay? But now, Q is going to be, let's make Q greater than 0. Okay? So Q is now greater than 0. What this means is this graph, okay, this point here is going to move upwards by Q units. Okay, whatever value q is, the graph, this one here, in under case 1, it will move by q units up. So when that happens, you are going to end up having something like this. If we move it by q units, it will look like that. Okay? The turning point is no longer at the x-axis. It's now there. So the turning point is now here. Here, x is still 0 and y is q. But q is no longer 0. Okay? Q is no longer equal to 0. It is any value which is greater than 0. Alright? And then you need to write the domain. The domain will remain the same. The domain is x is an element of real numbers. The range, okay, the range is going to be slightly different from case 1 because q is no longer 0. So the minimum value of y is going to be q at this minimum turning point. So we will say q is less than or equal to y, and y is less than or equal to infinity. Or you can write this as y is an element of real numbers, okay, but q, okay, but y, in fact, you say y is greater than or equal to q. Right? We can also write it as, I don't have enough space, but you can write it as y is an element, then you open your square bracket, we include the q, and we also include positive infinity. So there are 3 ways of writing it. Now you can decide which format you prefer. Okay, it is your choice in terms of how you want to write the range. Okay, but if the question comes, there are 3 ways of writing it for case 2. Okay, even for case 1, 2, I can add that here. I can write another way. It would be to say y is an element of real numbers, but y is greater than or equal to 0. So you can also add that. There are 3 ways of writing the range of case 1. Okay, then let's move on to case 3. Case 3. Is there anyone who has got a question before? So in case 3, A is still positive, but Q is now negative. So we are going to have a graph which looks like that. Okay, it will now be slightly different. Okay, it's going to look like this. It means that we are moving the first graph under case 1, we are moving it by Q units down. So it will look like this. Right? Now, the first 2 graphs, okay, let me go back. The first 2 graphs, okay, if you look at it, you find that the one for case 1 has got an x-intercept at x equal to 0. This one here, it has no x-intercept. Okay? It's very possible that a quadratic function may not have an x-intercept. The x-intercept can be undefined, like in case 2, because the graph itself is not touching the x-axis. So case 2, there is no x-intercept. Now case 3, we have 2 x-intercepts. There and there. Those are the x-intercepts. Alright? Now, here, that's where our q is. X is 0 because it's on the y-axis. Okay, on the along the y-axis, x is a 0. Okay? Then we need to write the domain. Now the domain does not change. Okay? It's still x is an element of real numbers. Alright? It's 2x is an element of real numbers. Then the range, right? The range, let me write it here. The range, okay? Here, that's where we have the minimum value of y, which is equal to q. Q is here, the value of y is q, okay? So, we'll say q is less than or equal to y is less than or equal to positive infinity. Or we can say y is an element, we include the q up to positive infinity. Or we can say y is an element of real numbers, but y is greater than or equal to q. So the way you write the range for case 2 is more like, is exactly the same as you write in case 3. Okay, so we have 3 cases when A is positive. Okay, we have 3 cases. That is when Q is 0, when Q is positive, and also when Q is negative. Right? Then let's move on to the 4th case. Case 4. Right? Now, case 4, our A is now negative. A can never be 0. Okay, I need to emphasize that. The value of the coefficient of x squared in the general equation A can never be 0. Because if it becomes 0, it means the quadratic function will cease to exist. Okay, so let's make q equal to 0. Now, because A is now negative, it means the graph will have a sad face. Okay? Graph will have a sad face. So it will look like this. Because q is 0, which means we are going to have value of q there. So when you sketch it, it will start from the bottom to now have what is called a maximum turning point. Right? So it goes like that. And here, we are going to still have x equal to 0 and y equal to q. But remember, q is equal to 0. So that point is 0.00. Okay? Then the x-intercept, there's one x-intercept there. Right? Then the domain. The domain does not change. It's still x is an element of real numbers. The range is going to be different slightly from the other 3 cases. Now here we have our maximum value of y, okay, and since the graph is now going down, it means that we now have to include minus infinity. Minus infinity is going to be the minimum, and the maximum is going to be the value of y at the turning point, and that value is equal to q. So, when we write it, it will be minus infinity is less than or equal to y, and y is less than or equal to q. Okay? But q is 0 for this case, or you can write it as, y is an element of real numbers. Okay? We are starting with minus infinity, and we go as far as positive infinity. Or you can also write it as y is an element of real numbers, but y is less than or equal to q. Okay? So that's how you write the range. Now you can decide which format you prefer. Now it's very important for you to know that from case 4, where A is now negative, the graph will have a maximum turning point. Okay, and we have one x-intercept, right? Let's move on to case 5. Now, case 5, for case 5, our A is still negative, but we are going to make the Q positive. Okay, so the Q value is going to be positive. When we have such a case, the graph of the quadratic function will look like this. When you sketch it, it will look like that. Alright? It will have a maximum turning point here. And at this point, x is 0 and y is q. It will have two x-intercepts. Okay? And then the domain is still x is an element of real numbers. It doesn't change. The range, okay? The range it's exactly the way we write the one for case 4. So we will say minus infinity is less than or equal to y is less than or equal to q. Or we can say y is an element of minus infinity up to q. Or we can say y is an element of real numbers, but y is less than or equal to q. We have to include the value of y at the turning point. It's very, very important. It has to be included. So don't make a mistake if you use the last format or the first one or even the third one to not put square brackets or to forget to put an equal sign. If you forget that, your answer becomes incorrect. Okay. Then case 6, which is the last case. So our A is still negative and our Q is now negative, which means Q is now below the Y, the x-axis. Okay? So when we sketch it, it will look like this. It will have a maximum turning point, so it will look like that. That's how it will look like. Right? And at this point here, x is 0, y is q. As you can see, there is no x-intercept because the graph is below the x-axis. Okay? The domain is going to remain the same. X is an element of real numbers. The range, okay, you write it like how we've been writing, so minus infinity is less than or equal to y is less than or equal to q. Or you can say y is an element, open this bracket, it's minus infinity up to q. And then you can also write it as y is an element of real numbers, but y is less than or equal to q. Alright, so those are the different types of shapes that you can encounter. So all the questions that you are going to encounter with regard to a quadratic function, they are going to be any one of those 6 cases. Okay? So don't get confused. The quadratic function may not have x-intercepts. It can have one x-intercept and to always have a maximum of 2 x-intercepts. Alright? Yeah. Is there anybody who has got a question? Our equation is f of x equal to ax squared plus q. So y will equal to f0. I hope you remember your function notation. Don't expect anyone to still get confused with this. It means the y value when x is 0. Okay? So that, which means we're going to have a times 0 plus q. So this will give us 0. So our y equal to f0 will be equal to q. So the y-intercept is going to be equal to q. Okay? So make sure you know that. And remember, q can be 0. Okay? Remember, q can be 0. If q is equal to 0, it means the turning point will be on the x-axis. Okay? So I've discussed the shape. I've discussed now the y-intercept. Now I need to move on to the x-intercepts. Okay? Number 3, the X-intercepts. I'm using the word plural intercept because it will have a maximum of 2. Here, f of x will be equal to 0. Okay? Or y, or we can write as y will be equal to 0. That's the same thing. Alright? Now, your x-intercepts, for you to find your x-intercept, you need your knowledge of quadratic equations. So, if the general equation is f of x equal to ax squared plus q, I need to substitute f of x by 0, then I'll get x. Okay? I hope you are following. Then I need to take the q to the left, so we end up getting minus q equal to ax squared. Okay? Then I will divide both sides by a. If I divide these two cancel out, so I'll be left now with x squared equal to minus q over a. Then I'll take square root of both sides. So x is going to be plus or minus the square root of minus q over a. Those are your x-intercepts. There you can find the x-intercept using that equation. And because of this plus or minus, it means you're supposed to have a maximum of 2 x-intercepts. Okay? 2 x-intercepts. Sometimes the x-intercepts may not exist. Okay? Sometimes the x-intercepts may not exist. It's very much possible. Okay? So don't be surprised if you find that the graph doesn't have an x-intercept. It means it will be above the x-axis or below the x-axis. Okay? It can also have one x-intercept, which means if it has one x-intercept, it means the turning point will be on the x-axis or it will be at the origin. For you guys, it will be at the origin. But in grade 11 and 12, it cannot be at the origin sometimes when there is one x-intercept. Okay? And let's move on to, okay, before I carry on, equation of axis of symmetry. Number 4. Okay, equation of axis of symmetry. Okay, please take note. It's an equation. Okay, that's very important. Right. Now, from your understanding, equation must be in terms of what? Because the x-axis is a vertical line. So it's like this. That's your y-axis. Okay, that's your x-axis. The x-axis is a horizontal line. So its equation is y equal to z. Okay? Because it's a horizontal line. And y is 0 here. Okay? The y-axis, okay? The y-axis, okay, so I was saying the x-axis is got an equation and the equation is y equal to 0. So if you are talking about the x-axis, your equation of the x-axis must be in the form y equal to 0. When you are talking about the y-axis, the equation is going to be x equal to 0 because here x is 0. Okay? And remember, if a straight line is vertical, its equation is x equal to. If it's horizontal, it's y equal to. So the equation of x of symmetry will be x equal to 0. Okay, that's your equation. Please, the y-axis is not the equation. The equation is x equal to 0. So if you're asked to write down the equation of axis of symmetry of a quadratic function, you don't write y-axis. No, you write x equal to 0. An equation must have an equal sum. An equation must have an equal sum. Okay, so the equation of the axis of symmetry of the quadratic function is x equal to 0. All right, I think for today